Okay, so today we are going to work with 5.3. 5.3 is still working with quadratics, but we're going to be doing so in vertex form. So it's graphing quadratics in vertex form versus before for 5.1 and 5.2 we were working with quadratics, but they were in standard form. So our goal today is going to be to identify the vertex, and translation from vertex form. Of a quadratic function. So to identify the vertex and translation from vertex form of a quadratic function. So the last couple class periods we've been talking about quadratics in standard form. So just a recall on that, standard form looks like this. F of x equals ax squared plus bx plus c. Remember that a cannot be 0 because if this term was 0, that term wouldn't be there, and then we would just have a linear function. So a is not allowed to be 0. And if you recall, we did learn how to find the vertex from this form. First, we had to find the axis of symmetry, which was the x equals equation. So your x was the opposite of b over 2a, and that ended up being the x of your vertex. Then we would plug in x to find the y value of your vertex. So that's how we would do it before. The parent function. So you'll remember way back when we were talking about absolute value functions, the parent function is the simplest form of a function. And we've actually brought up the parent function of a quadratic when we discussed that. I believe it was in like 2.5 or 2.6. But the parent function here would be the simplest form of a quadratic function. You could have zeros for these two terms. So if those went away, that would make this function simpler. And if a was 1, so it didn't show up, that would make it simpler. So the one thing that makes this a quadratic is it has to have that x squared term. So our parent function, which is the simplest form, would be f of x equals x squared. That's the most basic form of a quadratic function. Okay. Vertex form is going to look like this. F of x equals a times the quantity of x minus h, that's quantity squared, plus k. Okay? When you are looking at this, the vertex will be obvious. The vertex shows up in the equation. The vertex is going to be at h, comma, k. Now notice that the vertex, you're subtracting h here, and h is positive over here. So h is always going to show up opposite in the equation. So you just want to make a note of that. So it shows up opposite in the equation. The k is exactly how it looks in the equation. So if it's adding, then it's a positive k. If it's subtracting, it would be a negative k. One thing I want to point out is that both, whether it's in standard form or vertex form, have an a value. And that a value is going to be the same regardless. So both have the same a value. I'm going to write that over here. Okay. Remember, there's an important part of what a tells you. A will tell you whether the parabola opens up or down. Okay. So we are going to practice graphing in vertex form. So here we are given an equation in vertex form, and we're going to go about graphing it. First things first, it's asking for the vertex, but I actually want to notice the first thing in the equation is that a value. That a value is a 2. So right away we know that this opens up. Remember when we go to write up, I always write the U so it looks like the parabola, because then I can visualize what my graph, make sure my graph actually looks like that when I go to graph it. If it opens up, I can see that it's going to have a minimum there. Okay. When you are working in vertex form, standard form, we used to find the axis of symmetry first. Now working in vertex form, well, we're going to find the vertex first. It really doesn't matter. So the vertex here, I did that in red before, I'll do it in red again, is h comma k. So your h is this number here, so your h is 3. Remember, it shows up opposite in the equation, so since it's minus 3, it's going to be a positive 3 in our vertex. The 7 is going to be the y of our vertex. If you think back to when we were doing absolute value equations, you had to take the inside and set it equal to 0, x minus 3 equals 0. That's how we figured out that the vertex was at 3. You'd plug it back in, and you always would get that last number because this would turn into 0. 0 plus 7 is 7. That's where that comes from. The same idea that we did with absolute value functions. We also could tell that if it's on the inside, that moves right 3. And the number at the end says it goes up 7. Once you write that vertex, though, it doesn't matter because the 0.37 is right 3 up 7. It's talking about the translation from our parent function. Our parent function, its vertex is at 0, 0. So when you move the vertex to 3, 7, that translates right 3 up 7. Okay, so your axis of symmetry then, remember your axis of symmetry is that vertical line. So we're going to write it x equals, look up at your vertex here, what does x have to be? X has to be 3 because that axis of symmetry goes right through that vertex. All right, we already answered the opening up part. Let's find the y-intercept. Now, remember that your y-intercept, you will only ever have one of them, so we'll plug in 0. So you can do that with a calculator. So let's see, 2 times the quantity of 0 minus 3, square that, plus 7, we're getting 25. So 0, 25 would be our y-intercept. All right, next we are going to put our vertex down here in our table. So our vertex was at 3, 7. We're going to put that in the center of our table, and then we'll find more points from there. So 3, 4, 5, then we count down. 5, 4, 3, 2, 1. That should be enough. Although I do also know 0, so if you wanted to add in 0 here, 0's at 25. It's okay if you go further in the table. That'll probably help us when we go to graphing it anyways. All right, so what I'm going to do is I'm going to plug in each of these values. If I already have this typed in, that's really cool because on your graphing calculator, if you hit second enter, it'll rebring this up, and then it overwrites it, so just hit a 1 there. And that one's at 15. Second enter, plug in 2, and we get 9. Let's double check this one. Second enter, if we were to plug in 3, we get 7, so that looks good. Second enter, plug in 4, we get 9. Second enter, plug in 5, we get 15. Which is cool because we can see that mirror image, which we should with a parabola. The only time we wouldn't see that mirror image is if this vertex was not directly in the middle of 2 and 4. 3 is exactly in the middle of 2 and 4. So that's why we see the mirror image. If it was at like a fourth, and we found 0 and 1, 1/4 is not directly in between 0 and 1, so you wouldn't see the mirror image on your actual table. The next thing that we're going to do is we're going to come back to converting it to standard form. But if you were not sure how to work in vertex form, you could convert it to standard form, work in standard form this whole time if you were more confident with standard form. I'm going to show you how to convert it to standard form here in a minute. But let's actually plot these points since we have them. So 0 is up here at 25. So I went up by 2s, 2, 4, 6, 8, and I went up by halves on my x-axis. So 25 would be right there. 1 is at 15. There. 3. 2 is at 9. 3 is at 7. 4 is 9. 5 is 15. And I know where 6 is going to be because I already found where 0 was. So I'm going to plot 6 as well because it's on my graph. And when I go to sketch and I have to go off the graph, I'm going to make sure it goes through the accurate point. So sometimes you have to find more points that are than what is on your actual table because your graph has those points. So it's important that your graph also contains those points. So what I'm going to do is I'm now going to take and connect all these points. Remember, you want to make sure that bottom's very rounded. And there we go. I have a nice U shape. Do not make it look like a point down there because if it does, then it looks like a V and you would get marked down. So make sure you connect those points as smoothly as possible. Alright, so your x-intercepts here. Let's look at your graph. Where does it hit this x-axis? Never. So your x-intercepts are none. There are no x-intercepts here. I'm going to show you how you actually can use, if you do not have to graph this, you can use algebra in order to solve and find your x-intercepts here. So, if we were given this problem and I didn't have to graph it, what I would want to do is I know that x-intercepts are x comma 0, so what I would do is I would plug in 0 for y. So I would have 0 equals 2 times x minus 3 squared plus 7. The first thing I'm going to do is get rid of this extra term. So subtract 7 on both sides, and I'd get negative 7 equals 2 times x minus 3 quantity squared. So what I did was I subtracted 7 to get rid of that extra term. Next thing I'm going to do is I'm trying to get x alone. So x is part of this number that's being multiplied. So I'm going to divide by 2 on both sides. So I'm going to have negative 7 divided by 2, which is negative 7 halves, equals this set of parentheses squared. Okay? From here, what I would do is I would take a square root on both sides to get rid of that squared. But what you'll notice is you're trying to take a square root of a negative number here. The square root of negative 7 halves. It's a non-real number, which is what we get into in section 4, our imaginary numbers. But for right now, we don't know how to do anything with that, so that just tells us that there's no x-intercepts. Okay? So there are no x-intercepts because you cannot square root a negative number. All right? Your domain. So your domain here, you go both to the left and to the right. You would be able to continue and find where negative 1 would be. You would continue and be able to figure out where 7 is. You would plug in 8. You can plug in 9. You can keep going to the right as far as you want. You can plug in any number you want. You can plug in 100, 1,000,000, 1,000. You can plug in negative 100, negative 1,000,000, negative 1,000, any of those. So you can go forever to the left and to the right on this graph. You can keep going. It's just going to keep going up. So because of that, our domain is x as an element of all real numbers. Our range, however, has a minimum value. Because if we squish this onto our x or our y-axis here, our lowest number would be this point right here, and then we would shade in this direction. We would keep going. If I looked at this number line, and I was talking about this inequality, how would I describe it? I would describe it as y is greater than or equal to that number right there, which is 7. So for my range, what I'm going to do is this is going to be f of x, because that's what I'm using instead of y. F of x is greater than or equal to that minimum y value was 7, which you can see that from your graph here. At lowest it gets is, or from your table, sorry, or from your graph, it doesn't matter, is it gets is 7. So f of x has to be greater than or equal to 7. Okay? All right, so let's talk about converting this to standard form then. What we are going to do down here, we have f of x equals 2 times x minus 3 quantity squared plus 7. What you'll need to do is expand that x minus 3. This is a huge error, and I will tell you that that is a question that's on your exam, and every year I try to stress and stress and stress. What is the value of x minus 3 quantity squared? And every year I have so many people tell me this is the answer. That is wrong. It is not x squared minus 9, because what you're actually doing here is x minus 3 times x minus 3. If you have two binomials meaning two terms being multiplied together, so here's a 2-term, here's a 2-term, you're multiplying those two terms by these two terms, you have to distribute or FOIL. So first, you have x times x, then you'll have x times negative 3. So you'll have x squared minus 3x, then you'll have to distribute that negative 3. Minus 3x plus 9. So what you'll end up getting, this, show you that it comes over here, ends up being 2 times, when we expand that, what we get is x squared. You can combine negative 3x and negative 3x. That's minus 6x plus 9. You have to keep that in parentheses, though. When you square x minus 3, keep that portion in parentheses. That's what you're going to get. Because from here, I'm confident that you guys can go ahead and continue to simplify. F of x equals, distribute that 2 to all three terms. 2x squared minus 12x plus 18 plus 7. And now you'll have more like terms to add, so 18 and 7. So f of x equals 2x squared minus 12x plus 25. This is the equation in standard form. Now, these are the exact same equations. They are just written differently. So let's verify. There's something you can see from looking at this right away. Your y-intercept. If you plugged in 0 here, would you get 25? Because that's what I got here for my y-intercept, and I would. So your c value has to be 25, because you can see that in your y-intercept. Your a value is 2, and your a value should still be 2. That works. Plug in a couple of points. If you plug in 1 here, do you get 15? If you plug in 2, do you get 9? Let's try it. 2 times 1 squared minus 12 times 1 plus 25. When I plugged in 1, I got 15. Try plugging in 2. Change this one to a 2. Change this one to a 2. I got 9. So they're the exact same equation. They're just written differently. Okay? I do have another problem on the back, so we'll try this one. We'll go through this one a little bit quicker now that we already have the hang of it. So, our vertex is going to be, this one shows up opposite, so negative 3, comma, negative 8. It translates then, left 3, down 8. Our axis of symmetry is x equals, look to your vertex, it has to be -3. Our A value was 2. It's positive. This opens up. If it opens up, that means I have a minimum. Let's look for the y-intercept. 0, comma, what? Plug it in. 2 times 0 plus 3. Square that. Minus 8. 10. 0, 10 is our y-intercept. We're going to write our vertex here in the center of our table. So -3, comma, -8. -3, when I'm counting up, I go -3, -2, -1. I count this way, I'm going to be at -4, -5. I also do know where 0 is, so I could add that one in there. 0 should be at 10, meaning -6 should also be at 10. I'll put those in there. Okay. I'm going to plug these other values in I can actually hit second enter. When you want to change this, if you want to insert a character there, you have to hit second delete, because it's insert, negative, and then that's a 5. You can hit delete on the 0. So -5 is being inputted. That's at 0. Second enter will change it to -4. That's at -6. Change it to -3 just to check. We're at -8. Change it to -2. We get -6. And when we plug in -1, we get 0. And I already plugged in 0 and got 10. We can double check and make sure -6 though. Oops. -6 is also at 10. And it is. So we're good. So those couple extra points we added are accurate points. Alright, so just going in order here, converting it to standard form. Okay, so f of x equals 2 times x plus 3 squared minus 8. If you want to write that off to the side, you can, or you can keep writing it right in there. F of x equals 2 times, we're going to take x plus 3 times x plus 3 minus 8. The answer of that has to be in parentheses. So many years in a row I see students that just forget about the 2 and they'll put that answer. They're like so focused on that they forget about the 2 out front. So when I FOIL this, first times your first is x squared. Your outside is 3 times x, so plus 3x. Inside is plus 3x. And your last is 3 times 3, which is 9. Okay, next thing we're going to do, distribute that 2. This will actually be 6x, so you can combine it in there. Next, combine those like terms. And something to double check, is your A value still 2, which it was up in the original? Yes. When you were to plug in 0 here, are you going to end up with 10? Yes. If you were to take the opposite of B, divided by twice A, so -12 divided by 4, -12 divided by 4 is -3, that's the x of your vertex. So everything appears to be the same. Double check that stuff. Okay? The x-intercepts. So that was my standard form. Let me box that in. Okay? The x-intercepts. This is going to be x comma 0. So at this point, you already might be able to look at your table and see this, but I want to show you how you would algebraically solve in case this was just a problem given to you. So I'm going to plug in 0 equals 2 times x plus 3, quantity squared, minus 8. First thing you're going to do, add 8 to both sides. Next thing you're going to do, divide by 2 on both sides. Next, what we're going to do is square root both sides. Now, when you take the square root of 4, your answer could be 2 different things. Your answer could be 2 equals x plus 3, because when you square root this, you're left with just the square and the square root undo each other. Okay? The square root of 4 could be 2, because 2 times 2 is 4. There's another possibility. Negative 2 times negative 2 is also 4. So your other possibility is negative 2 equals x plus 3. The square root of 4, if you type it into your calculator, square root of 4, it's going to tell you your answer is 2. But really your answer is going to be a positive or negative 2. Your calculator only tells you the principal root. That's what that's called. So we still have to solve for both of these. So subtract 3 on both sides. You're going to get negative 1 equals x. Subtract 3 from both sides. Negative 5 equals x. Okay, now we still have to write it as an x-intercept though. Those are what we got for our x values. But we still have to write negative 1, 0 or negative 5, 0. And if you look down here at our table, negative 1, 0 was a point in our table, and negative 5, 0 was a point in our table. The domain. I could keep finding values of my x. When I fill in my table, I'm filling in the x values. I could find a 1, a 2, a 3. I could keep going. So my domain is x is an element of all real numbers. Now your range, though, depends on whatever this is, right? So what's happening is you have a negative 8 point, and then your numbers keep going up on both sides. So this is a minimum. This is the lowest the y will ever be. So f of x has to be greater than or equal to that 8 value, which is the lowest y value it's going to be, because these keep growing on both sides. So all your y's are going to be greater than or equal to that negative 8. Sorry, I wrote that wrong. Okay. Next, we are going to graph this. So since I have majority of the x values are negative, I'm going to put my y-axis over here. I have to go to negative 8 and positive 10, so I'll put it kind of there in the middle. That should be good. So this will be at, no, I want to go up on my ones, or twos. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. And I should be able to go up by halves. So let's see, I want to go down to negative 6. So negative 1, 2, negative 3, negative 4, negative 5, negative 6. That should work. Okay. So now that I have my scales on there, what I'm going to do is I'm just going to plot all these points. Negative 6 is going to be at 10. Right there. Negative 5 is going to be at 0. Negative 4 is at negative 6. Negative 3 is at negative 8. Negative 2 is at negative 6. Negative 1 is at 0. 0 is at 10. Now I could find where 1 is. I could plug that in and figure out where 1 is. And that's at 24. So I know that 1 is way off the graph. I could also figure out where 0.5 is. So I can make sure if these are on the graph, I can accurately plot them. 0.5 would be at, that's at 10. No, 12. Would be at 16. Which would be also off the graph up there. So I know that when I go to connect my points, I want to make sure I'm off the graph before 0.5, because I don't want to accidentally graph that wrong. Something like that would be our graph. And that's all I have for you today.